Here's problem 2.7. A rocket initially at rest is fired vertically with an upward acceleration of 10 meters per second squared. At an altitude of 0.5 kilometers, the engine of the rocket cuts off. What is the maximum altitude it achieves? We have to treat this in two stages. We first are shooting the rocket off. It has an initial velocity of 0 in the y direction. It's going to go to an altitude of 0.5 kilometers, so that would be 500 meters. And what else do we know? Well, we're told it has an acceleration, given acceleration of 10 meters per second squared. Now, regardless of gravity, that's already figured in. This is the acceleration for the motion. So we don't have to worry about figuring in gravity with that because it's already figured in terms of the motor overcoming gravity and achieving this acceleration. So that indeed are our three kinematic variables for the first part of this leg. But then we're going to have a second leg when the motor shuts off. And so this is really two problems in one. Yay! So we have that in our second leg, what do we know? Well, we know that our final velocity is going to be 0, because eventually it's going to reach as high as it can go and go no further. The motor is shut off, so we're strictly under the acceleration of gravity, and since we're assuming our initial velocity for this leg is up, the acceleration of gravity would be a negative 9.8 meters per second squared. What is our initial velocity? We don't know, but it could be the final velocity from leg number 1. So if we calculate that, we can find out the initial velocity in this leg, and eventually we want to find what is our displacement for the second leg. So we have a displacement for the first leg of 500 meters. Alright, so let's look at this first leg. And as we said, acceleration is 10, initial velocity is 0, displacement is 500, and we want to find our final velocity because that will be our initial velocity for the second leg. So, checking our kinematic equations, we will look at a kinematic equation number 3. Final velocity equals initial velocity, final velocity squared equals initial velocity squared plus 2 acceleration displacement, in this case displacement delta y1. Our initial velocity is 0, so our final velocity is going to equal 2 times the acceleration, 10, times displacement, 500, square root. So that is going to be 10,000 square root, or 100 meters per second. That is the final velocity of the first leg. That will be the initial velocity in the second leg. So I can write that down now. Initial velocity will be 100 meters per second when we start this second leg at that point. So, looking at the second leg of this journey, we have an initial velocity of 100 meters per second. We have a final velocity of 0, because it's going to go as high as it can go and go no further. Acceleration is a negative 9.8 meters per second squared. We want to find displacement. Well, again, we can use kinematic equation number 3. Final velocity squared equals initial velocity squared plus 2 times acceleration displacement delta y. In this case, our final velocity will be 0. And so we have a negative v naught squared equals 2 acceleration delta y, or delta y is equal to a negative v naught squared over 2 times the acceleration. That's going to be a negative 100 squared over 2 times a negative 9.8. It's a good thing we have a negative negative to cancel out. So that would be 100 squared divided by 2 divided by 9.8. That is 510 meters. Our final displacement is going to be the sum of these two displacements, delta y1 and delta y2. So that's 500 plus 510, and that will give us an altitude of 1,010 meters. That's how high this rocket will go, 1,010 meters, or we could say 1.01 kilometers. And that's the answer that we're looking for.